So this is me. I'm the one on the left. I'm a front-end developer who, up until May, was living in New York City, where I lived for 20 years. Now I'm here in Atlanta. I'm very happy to be here. And I actually work for a New York company called Bounce Exchange. And I work from home because they're in New York. So this is the first time since I moved to Atlanta that I've been in a room full of other developers. So it's pretty awesome to see all you. I mostly see the walls of my apartment. And as it happens, two of my coworkers are sitting back there who also work remotely. Andy and, I'm sorry, David, who live in South Carolina? Yeah, good, I got it right. Who also work for Bounce Exchange, which does behavioral marketing, which means when you go to a website, if you're a client of Bounce Exchange, or if the website is a client of Bounce Exchange and you visit that site, it will look at what you're doing, what you're scrolling to, what text you've read, what you've done, and respond by changing the ads on the site or changing the site somehow in a way that will hopefully be interesting to you. Okay, right, that sort of thing. I've also been asked to say that we're hiring. So if you're a front-end developer with mad skills, you can go ahead and contact me there, and I'll forward your information to the powers that be if you would like to work from Atlanta for a New York company. Anyway, they're pretty awesome. So yeah, before then I was at AOL, Bloomberg, and a bunch of other companies. I spent about a year doing Angular, and then about a year doing React stuff, and now at Bounce Exchange we're doing mostly Ember. So that's been kind of interesting, odyssey of going through immersing in all those different frameworks. I have a whole other life as a theater director. So anybody wants to talk about that, and I can talk about that too. But let's talk about generators. This is an incredibly bad pun down there, JavaScript that yields to the greater good, which you'll understand. I don't even know if I can dignify it by calling it a pun. I don't know what it is. But the first thing we should talk about is what do generators generate? They actually generate something called an iterator, or iterators. So I want to start by talking about what an iterator is, because it's what you get out of a generator. This is literally, if you had a generator, which is a kind of a function, you would get an iterator from it this way. Most people don't talk about it that way that I've heard. They just talk about both the generating thing and what you get out of it. I hear people call them both generators. And I think that's technically wrong. The generator is actually the factory that makes the iterator, but that's what you'll just hear all the time. So people have to get used to it. But I'll try to be a little careful about what I'm saying. So an iterator is an object with a next function on it. So that's kind of the most basic definition of what an iterator is. And you can think of it kind of like an array. If in order to get a value out of an array, you had to call .next on it over and over again, and each time you call .next, you would get the next value from the array. So it's kind of like that. More specifically, each time you call .next, if we said we have an iterator here that somehow by magic that I haven't told you yet got values inside of it. But if we already had this and the values inside it were Mo, Larry, and Curly, if you called the next the first time, you'd get this object with a value Mo and done of false. And then you call it again, and you get Larry, done false, and then value Curly, done false. And then the next time you called the iterator, you would get the value of undefined and done of true. So you could work with an iterator yourself if you wanted to loop through it just by continually calling next and each time checking to see whether done was true or false. Does that make sense? I don't have any swag. I don't have any Nutella, but you can still ask questions if you want. All right. The other thing that you can do with an iterator is use this for of loop. So that basically does what I just said for you. the for of construct keeps checking to see whether done is false, and then it will just stop. So you don't have to look at that object with the value and the done. The loop will just pull out Mo, Larry, and Curly, or whatever's in there. So that's literally built in. That's magic voodoo behind the scenes, under the hood stuff. Somehow for of knows to do that. That's literally what the for of loop does. It checks. Yeah. Literally, if you had some other thing like is finished instead of done, it wouldn't work. That it checks for, yeah. It's going to get even weirder. So here's kind of an example of me creating my own iterator. This is not something that you would probably do. In fact, I've never done this because we're going to use generators to create them. But just so you kind of conceptually can see this, this would be a really simple iterator. It's just got a next function, and the next function will either return, Mo, Larry, or Curly. When it's eaten up that array, it'll return that bottom function with the done. That actually would not work with the for of. To make it yourself work with the for of, you have to add a little more sort of boilerplate to it, which again, other than this talk, I've never done this. But just if you have to use this thing called a symbol iterator, which is part of ES6, and I'm not going to get deeply into this right now, but what I want you to see is the bold part is exactly what I had on the previous slide. So all of that other boilerplate with the symbol.iterator is just to allow the for of to understand what this actually is. And this is what generators are going to spit out. So much easier than what was on this slide. Here's how you could build an iterator with a generator. It actually is that simple. So a generator, and this is where we're going to start doing our deep dive. A generator is a special kind of function. There's some totally new constructs here if you've never seen generators before. The first one is the little asterisk in between function and my generator. You can kind of stick that, in terms of white space, you can kind of stick that asterisk anywhere. You can put it right after function. Or you could put function space, star space, whatever. I like to do it that way where it's right before the name, but that's just me. So that tells the JavaScript interpreter that this is a generator function, not a regular function. And then whatever you want the iterators spit out each time someone calls next, you just put after these yield statements. So this will create just what we talked about on the previous slide. You do this, you then create your iterator. Okay, so remember, the generator is not the iterator. The generator spits out an iterator. So I have to call this line where I say, my iterator equals the return value of my generator. Then my iterator now is now an iterator, and I can call next on it and get Mo and Larry and Curly and then done. Or I can do the for of. Everybody with me, like just to this point? This is all ES6, right? And all the code on these slides, and I'll put up the URL of the slides again at the end, but all the code on this I ran in the latest version of Chrome, and it all works in there. For real production stuff, I would still, I'm sure, be doing this like, Bagel or something like that. I looked at it once, and it's pretty hairy because JavaScript doesn't have anything like yield built into it, so it's not pretty. Yeah. Okay, I want to talk about yield, because yield is really, really interesting. And if you haven't worked with generators before, it'll be a completely new idea to you. It certainly was to me. So what yield does is it is kind of what it says on the tin. It actually yields the function. It will pause the function right where the word yield is. So if you have a function that has multiple yields in it, the first time you call it, or the first time you call the iterator that's returned, it will run the function up to that yield and then pause. And then you call the function again, it will run up to the next yield and then pause. If you have some kind of loop inside the function, like a while loop with the yield inside, it will keep pausing that while, rather than just running and running and running, it'll do a while loop and then pause at the yield. Then you call the function again, it will resume the while loop and pause at the yield, so on. The giving away the end of this right now, what I want you to start to see is that's really exciting for asynchronous. The idea of a function that can pause is really exciting for anything asynchronous because you can write in that function what looks like synchronous code. You can just say, well, go get this value from this website, yield. Go get this value from this website, yield. Go get this yield, and you can have it wait for all of those asynchronous things to be finished. You then do need something outside to keep calling that function again and again and again and again, and we'll get to that in a minute. Pardon me? Yeah. Yeah, and I think the answer to that is yes, but let me move forward and it may become clear, and if it doesn't, ask that again. Okay, so I wanted you to see the example here. I ran myiterator.next, and I got foo. But I didn't get that boz value. I then just did a console log for bar and got that. And then later on, I called my iterator again. I called my iterator.next again, and then I got boz. Okay. And we'll go through a much more complex example of this in a minute. Say it again. It only works in generators, yeah. So the other interesting thing about yield is it acts as a gateway to allow you to get data into and out of generators. This is, by the way, is the part of generators that took me the longest to understand. So if you don't understand this in the first go, don't beat yourself up. Again, I've linked to these slides and to other resources so you can go through it as many times as you want, but I'll try to explain it as clearly as I know how. So if you put information after the yield, you don't have to. You can just use yield just to pause a function. But if you put a piece of data after the yield, like the blue foo that I have here, that's what will get spit out of the iterator at that point. So you saw that with the Mo and the Curly and the Larry. If you put something, if you put something here on this side, like the green text there, and set it equal to the yield, that's how you will get information back in to the iterator. That's probably not going to be 100% clear yet, but what I want to do on this slide is not fully explain it, but just get you used to the idea that there's input and output here. And I just did a little example down at the bottom where you saw the first console log before. That's really similar, where I'm just getting that foo out. On the next line, I'm calling next, but I'm giving it a parameter, bar, and I'm sending that back in. So received from outside, that variable is going to be set equal to bar. And again, I promise we'll go through I'll explain that a little bit more fully in just a second. Here's where I just say this is, I think, the trickiest thing to understand is this I/O part. So go over these following slides until you get it, even if it's not right now. I really had to work through an example a bunch of times, and then the light bulb went on. So this is the full example we're going to go through, and we're going to go through it line by line. And any of you who know generators really well, I apologize because you'll be bored during this. Those of you who if I run out of time, this will be the most valuable thing for us to. So I don't want to run out of time for this. I'll go through all this as slowly as we need to go. So this is the basic code we're going to use. It's pretty simple in terms of it's going to yield, give me some Java, and the next time give me some script, and then it's just going to do a console log at the end. But we've also got these things A and B in there And if you look down to the bottom, the second 2 times I'm calling next, I'm sending in Java and sending in script. So what's going to happen, in a way that hopefully you'll understand in a minute, is A will be set to Java, B will be set to script, and that final log, console log, will say, what did you give me, JavaScript? So let's do this as if we were running a debugger and just doing a step through here. So I start by using my generator to get an iterator called kick-ass-iterator. And that's all I'm doing for now. So for right now, I've just made my iterator. Okay, now, here's where it's going to start getting fun. I'm going to call kick-ass-iterator.next. And what that's going to do is run that much. One thing to remember here is that in a line like that first one with the const A, JavaScript is going to run that from right to left. That's nothing to do with generators, that's just how JavaScript works, right? If you have an assignment, it always does the right side of the assignment first. So the first thing that it's going to do is yield, give me some Java, and then it's going to pause, because it always pauses at a yield. So that const A, strangely, even though it's on the same line, is not run yet. And that's just because that's how yield works. It will pause mid-line. It will pause wherever the yield is. So that gives us this. We'll now see in the console that the value of the first yield. Okay, now we run this next line, where we're sending Java into that. And now it's going to be like we've started the DVD player or whatever tape player running again. So now the pause stops, and A gets assigned to whatever we've just sent in, that value, that string Java in this case. And it will now start resuming until it hits another yield. So it will now yield out, give me some script, and then pause. So now so then that second console log down at the bottom. Okay, now I'm going to run this final .next and send in script. So it resumes, B gets assigned script, and it just keeps running till it hits another yield. In this case, there is no other yield. So we get, what did you give me? JavaScript. And you can see that down at the bottom, and then done becomes true. And if that was unclear to you, I'm happy to answer questions, but if that was unclear to you, as it was, first of all, if that was crystal clear to you, then you're smarter than I am, because it really took me a bunch of time. If not, what I urge you to do, again, I'm going to give you you can ask questions if you want, but I'm going to give you the link to this presentation and also to other resources about this. And I think if you go through this a few times and look at, 1 or 2 other articles about it, and of course, best of all, go to CodePen or JS Fiddle and try a couple. Use yourself. I think you'll start to get this. The key here is, still, the key takeaway is that we can send information in and out of these generators and make them pause whenever we want to. Yeah, question? Great question. You can yield anything. Any value that you can send around with JavaScript. So since functions are first-class objects, you can yield them too. You can think of yield kind of like return. Anything you can return, you can yield. Okay. Yeah, sure. That's a really good question. Let's think about that for just a second, right? So you call next with foo or whatever. It's going to run all the way up to that yield, and then that foo will just get lost. There's no way for it to go. So the answer is no. Yeah, the very first time, there's no point in passing a value in. Yeah. It executes this, what this does is it creates the iterator. Yeah. So if you've ever worked with like a factory pattern, that's essentially what it is. Generators are factories that spit out iterators. Yeah. You can't, there's some, if I think I understand you, there's some behind the scenes magic that you're not quite seeing. Like, notice that I haven't put a parameter in there. So literally how that value, the Java or script or whatever, gets into A or B, that's stuff that's happening under the hood that you can't see. Which is a little confusing if you're used to having a function with properties in it. One way to think of it is yield. I don't know if this will be helpful or more confusing, but yield is like a return that returns in two directions, right? The first yield there is going to return, give me sub Java when you call next, but it's also going to return something to the const A. So that yield resolves to whatever you pass into it, right here. Very, very strange kind of Alice in Wonderland concept, yeah. Mm-hmm. Now, if you ran it again, you would get, what did you give me? Undefined, undefined. If you ran it again with like this, oh, I see what you're saying. No, yeah, it's empty now, it's done. Yeah. But if you ran this line again, except you changed kick-ass iterator to kick-ass iterator 2 or something, you'd then have a new one that you could do. Yeah, there was another question. Yeah, sorry. Well, it does return something, but it's by another mechanism besides return. The return will happen at the very end, I believe. Yeah, the return will happen. It'll be the last thing that will pop out, and then you can set something equal to my iterator, whatever. Yeah, and it will terminate it too. Yeah, I've used that before, just if I didn't want it to keep running. So you can, if you put a return in between these two yields, you would never get to the second yield. Yeah, question. Uh-huh. Mm-hmm. Yeah. Mm-hmm. The stuff on that's a good way of thinking of it. The stuff on the stuff to the right of yield gets sent out to our universe. If you want to think we live outside the generator. Yeah. Yeah, I think somebody over your direction, maybe it was you, asked about that earlier. It's really ugly because a fun assignment. I don't know if this is fun, but maybe it's fun. Fun assignment would be try to create generators yourself. Yeah. Right. Right. Yeah, I looked at it once and sort of looked through it and worked through it, and I can't remember everything, but it's a lot of code because it's complicated to try to build something that is sort of like a function but pauses and all of that. So yeah. I mean, it just has to do a lot of caching. It's an object that has to cache stuff. So that's what it sort of gets converted into as my memory. So the beauty of this, which is what we're going to now start to get into for asynchronous stuff, is that you can write asynchronous code that looks synchronous. Like step 1, do this. Step 2, do this. Right next to each other, like this, with nothing in between them that says, yeah, but wait, don't do the second thing till you've done the first thing, because you don't need to do that. You can just say, pretend as if the whole world was synchronous. Get the user, okay, I'm just assuming you have the user now. Now get, his comments or whatever. The unfortunate thing is, in order to do that, you can do that because, like I say, the iterator will automatically pause at each yield. But in order to do that, you have to have this ugly stuff that runs the iterator. You have to have some other code that outside of the portal that is starting and stopping the iterator at each of your steps and waiting until something happens, waiting until a promise returns or whatever. So that's sort of the bad news. The good news is all that code is already written. So that's what things like Redux Saga, if any of you work with Redux, does. Co is another one. There are all these libraries that take care of all the starting and stopping of iterators so that all you have to do is write the synchronous looking code. So that's what I want to talk about now. And I'm going to, but if you had to write it yourself, you might have to write kind of ugly nesting, stuff like that. And I'm going to show you now a very naive implementation of this. And again, I don't want to linger on this because we could spend the next hour talking about this code and also what's wrong with it. There's a lot of stuff missing from it, like error handling, not there. So it was what I could fit on a slide. But this stuff you should never be writing yourself unless your goal is to write some kind of generator library, because it's all been written before. But essentially, if we look at this, okay, I've written something that I call generator runner. And I probably violated my own rule here. I probably should have called it iterator runner. That's really what it's going to be running, an iterator, not a generator. Okay. So you give it a generator. You can see on the first line inside the function there, it creates an iterator from it. And then I've got a loop down here in the form of, I've just done it as a recursive function that calls itself. You can see the function's called iterate. And then down below, in kind of the last line, you can see iterate is calling iterate. And so what's going to happen is this function iterate is going to call iterator.next over and over and over again. It's going to keep calling iterator.next. It checks to see if done. There's that if in the middle, it checks to see if done is true. And in that case, it's going to stop, essentially. But as long as done is still false, it's going to keep calling next, 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 next. There's a really ugly thing in there with a timeout, which I don't want to go too deeply into, but it just has to do with it's the timeout with zero. It's got a zero at the end, so it's the shortest timeout you can possibly run. There's kind of an under the hood step where you have to wait for the next frame, or whatever you want to call the next part of the run loop, to happen before this can resolve itself. So that's just part of how these have to work. And again, if you want to read more about how to do this, and what all this means, I'll have to link you to some articles at the end. But the real takeaway is I've written this mechanism that is just going to do the next for me over and over and over again. So what's great about that, now that I have that thing called generator runner, here is how I would use it. And this is also how you'll use libraries that are similar to what I just showed you. You just call that generator runner function and you give it a generator. And inside there, you write all the steps that you want to do. So, I'm getting data from an endpoint, getting data from another endpoint, getting data from another endpoint. I have an actually running example of this on a JS Fiddle down there where I've kind of written all of the boilerplate code if you wanted to go to that and see that. And again, I'll put this up, the URLs up at the end of this. But that's literally what you would do. It's just da-da-da-da-da. This is where we hook my talk up to Mark's talk. You would want each of those functions get data, which is just something I made up. But each one of those you would want to return a promise. So each one of those return a promise, get data, get data, get data. But this is the beauty of it, is it allows you to just do this and not have to have all kinds of callbacks and other stuff in there. So here's an example. I didn't realize my text on top ran over like that. Sorry. Here's an example, a real example using Co, which is one of the big libraries that people use for this. And you'll see it looks very much like what I showed you on the last slide, hopefully. So here I've made more kind of realistic, I guess, things like get user, get comments, get responses. And each one of those should be, each get user, get comments, get responses should be similar to what, something similar to what Mark showed you in the last talk. It should be something that returns a promise whenever, you know, one of those async things is done. But you'll have all your steps here just in this neat little column. Do this, do this, do this, do this. And what Co does is when all of the yields are finished, it just keeps looping through. When all the yields are finished, it then returns a promise. So then you can use a then to say, okay, now that all of this is done, here's what I want to do. And you put a return. So one of you asked about that earlier. You put a return at the end of your generator code here. And that, whatever you put right there as the return is what's going to get typed into the then function parameter. So again, if you've ever had to do like really complicated asynchronous stuff, this should hopefully look really pretty to you. Like, wow. Just pretend as if all this timing stuff does not exist. And what I want to show you here is you can now, and this is where I was really like, whoa, you can now use all of these synchronous constructs that we all used when we first learned how to program, like while loops, in asynchronous situations. So here's an example where I want a score in a game just to be constantly pulled. Something called get score. It's going to go out and look for the score over and over again. So I just put it in. I mean, that looks like it should be like it should cause a crash because I just put while true. But it's not going to crash because there's a yield in there. So it's not going to just keep going and you know, eat up all of the RAM or whatever. It's going to just run up into that yield and then pause. And then when this is resumed, the while loop will continue, but it will pause when it gets to yield again. And pause when it gets to yield again. And pause when it gets to yield again. This, by the way, is part of the reason why, remember a few slides back, I had to have that set timeout in the runnable, is just to make sure that we aren't externally to this doing yield without letting other frames play in between. But again, you won't have to do that set timeout, hopefully, because you're going to be using Co or Redux Saga or something that will just take care of that for you. And make sure that at least one cycle happens between those. Yeah. Right, when that promise resumes. Now, not by magic. The reason why get score's promise resolving will cause this to continue running is because of Co. Co is listening to the promises and going, oh, they're done? Well, then start this up again. That's another thing that took me forever to understand about these because there's so much that you're not seeing that's going on. Yeah. Right. With promises. Absolutely true. With generators. Yeah. Absolutely, yeah. And the nice thing about that is, you know, it's decoupled in the sense that if we start to use generators, we like that idea of generators, but, you know, in 3 years or something, we've all rejected promises. We want some other thing that's kind of like promises, but it's totally different. We could still use it with generators. Or, you know, we could reject generators and still use promises. So it's sort of nice to decouple that way. But yeah. So yeah, Co is checking the results of every yield. See, is it a promise? Is it resolved? Oh, it is? Okay, start the iterator rolling again. And just to go back a little bit, that's what, in a very naive way, I'm doing here. You can see there's a function there called isPromise, which I've also written down in the second if. there. And my version of isPromise just checks to see if object.net has a .then function. So all kinds of things that are not robust about this, but I just wanted to give you the idea of a naive way you could write something like this. Resumes whenever it finds a promise. Here's another example just with an if, as opposed to a while. So I've got one yield up at the top that will definitely run. When this gets resumed again, there's a second yield inside that if statement that may or may not run, depending on whether the game score is over 1,000. I should also say that the other thing that Co is doing and that the other libraries are doing is so remember that generators, the yield is like an I.O. It will both send data and receive data. So what Co is doing is when it gets data from a yield, it's sending that same data back in to the yield. So that each one of so that you can essentially keep sending that data down the chain. So you've got a yield that yields out the result of some asynchronous thing that's getting a list of users. So that promise fulfills, the list of users come in. Co will then take that list of users and throw it back into the iterator. So in your next step of the iterator, synchronously, as far as you're concerned, you can say, oh, okay, I've got my users now. Now I want to find all of the blog comments they've written. So then all the blog comments will get sent out. Right? And then Co will take those blog comments, send it back into the iterator. So the iterator will go, okay, I've got the comments now. Now I want to, know all the dates on them or whatever. So that's another part of what's making this work. Is something else externally orchestrating the I.O. Yeah. Right. And that's one of the things that's wonderful about yield is that it yields. It yields to external code. So you're never going to lock anything up. Yeah, question? I'm sorry. Right. It can, although notice that there's still a then down at the bottom. There, at least that's with Co. So Co essentially takes what might have been a complicated chain of thens, and then allows you, if you want to say, no, I'm just going to treat this as if it's synchronous code, but I'm going to have one. It can't get away without, if I have one then at the end, just to deal with the fact that this entire thing is going to be asynchronous. So yeah. Question? I'm sorry, I missed that. I don't know because I'm not a C#. Does anybody else answer that? Okay, yeah. Yeah. Any other questions? Yes, yes, and I actually replicated that. Yeah, you see where the code that's in bold, that it's got the value, that's the value of the last time through. So my version of Co here is choosing to send that value right back in. And that's what Co is doing too. So that is basically all I've got for you guys. I can answer questions, but I wanted to leave you with, there are 4 articles. A lot of you probably know Kyle Simpson, wrote some really good books on JavaScript, and they're the You Don't Know JS series. He's got some really good stuff about promises and generators in there. He's also got 4 articles that if you go to that site, will go through everything that I just went through with more depth, and of course you can read it so you can go through it much more slowly if you want to. The Mozilla article about generators is pretty good. Co and Redux Saga are the two libraries that I see people talking about the most with this. Co is more general purpose. You could use it with anything. Redux Saga is specifically to work with Redux. And you can do that. And I wanted to just do a little nod here to maybe what will be the next talk at some point, because, and you, I think, mentioned this a minute ago, that kind of the next phase in the evolution is async await, which I believe is ES17, as opposed to whatever the next one is. So this will kind of take this idea of writing asynchronous code as if it was synchronous code, which is kind of what everybody wants, one step further, hopefully make it one step easier. So you can already read about that if you want to, and I've given a link down there for that. And up at the top there, the link that's in the orange is this deck of slides if you wanted to go through that like step by step or any of that again. Any other questions? I'm done. Thank you.
Awesome. Thank you.